Alright, just doing more factoring, showing you more and more examples to put in your notes, and then hopefully you can use some of those examples and different ideas to help you as you do your practice problems. Okay? I'm actually going to be nice here and review one more time the special factoring rules, the sum of two perfect cubes. So we're going to factor 27m cubed plus 1. 27m cubed plus 1, we're going to factor that. And if you look in your notes from last week, you should see a special factoring rule with the sum of two perfect cubes. A cubed plus b cubed. Yep, that is the one. Okay. That is the special factoring rule that we would be using here because these are both perfect cubes. These are both perfect cubes. I have something cubed plus something cubed. Okay? 27m cubed is a perfect cube because what times itself 3 times is 27m cubed?
3m.
3m. Yep, 3m. 3m times 3m times 3m gives me 27m cubed. And what times itself 3 times is 1? 1. Okay? So what you have here is you have the sum of two perfect cubes. Alright? So you're going to be able to use your a cubed plus b cubed rule, which is from your notes. Okay? Okay? Here's your a cubed plus b cubed rule that you're going to be able to use to factor this. But instead of a cubed, we have what? Well, we have 27m cubed, but I could write it as what cubed? 3m cubed. Okay? So really I have 3m cubed plus, and instead of b cubed, I really have what cubed? 1 cubed. So all you're going to do is you're just going to follow this factoring rule, but in place of every a, you're going to put a 3m, and in place of every b, you're going to put a 1. So it's really pretty simple, because again, I'm going to give you this rule on your test if you have to use this rule.
So you gotta write it down.
Yeah, I'll write this rule right here down. Yeah.
All right.
Yep. Or type it out or whatever. So instead of a plus b, what am I going to have?
3m plus 1.
3m plus 1. Instead of a squared, what am I going to have?
3m squared.
Which would make how much?
9m.
9m squared. Minus a times b.
So it'd be 3m.
3m.
What's 3m times 1? So minus 3m. And plus b squared.
Plus 1.
Plus 1. Yep. And you're done. Okay? You will never be able to factor that quadratic back here any further. Anytime you have the sum of two perfect cubes or the difference of two perfect cubes, once you've done this part, you're done. That's all the further you can go. Questions on what we did up there, guys? Again, you got to do a few. Yes.
You're going to give us these factoring rules.
The cubes, just the cubes.
Yeah.
Yeah, not the difference of two squares. You got to kind of know the difference of two squares. I will give you this line right here.
Okay.
I'll basically say, use this to help you factor this, and then you got to be able to do that part. Here's your answer right here. All right. Drew.
For the a squared,
Yep.
wouldn't it just be 9m? Because don't you, like, once you square it, do you just leave the squared up there? Or?
Well, what is really our a value? What are we using instead of an a cubed?
3m.
3m. So 3m is our a value. And this says to take your a value and square it, which would mean to take that a value times itself. So you got to think of what would you get if you took 3m times 3m?
9m.
9m
Oh, yeah.
squared. You get 9m squared
Oh,
because anytime you take an m times an m, you get m squared.
Yeah.
Does that make sense?
Yeah.
Yep. So yeah, so just kind of be careful on that. I like writing this out, guys, right here. I like writing this step out. You don't have to, but the reason I like writing this step out is because then I can easily see, okay, instead of writing any of the a's, I'm going to be writing a 3m, or it tells me basically what to substitute in for each a value. If I substitute 3m in place of an a, and I substitute 1 in place of a b when I'm just following that rule right up here. Okay with that one? Okay. Next. Let's factor 2x to the 5th minus 162x. Again, it's kind of the same process over and over again. First thing you should always look for, greatest common factor. Yep, very good. What is our greatest common factor going to be here?
2x.
2x. Yep. So I got 2x. What's left over? X to the 4th minus 81. What do we got here?
X squared minus 9 x squared.
Very good. Difference of two squares. Yep.
Plus
X squared plus 9 and x squared minus 9. These are both perfect squares. What times itself is x to the 4th? What times itself is x to the 4th? X squared. What times itself is 81? 9. Is there a difference of two perfect squares then? Yep. One's a plus b, one's a minus b. Remember that rule? So now I'd have 2x and then x squared plus 9 and x squared minus 9. Done?
No,
Nope.
judging by your smile.
What else?
x plus 3.
Same rule again. No cubes up here.
Oh, difference.
Here it is again, right? Difference of two squares. So what would that be? X plus 3, x minus 3. Can I do it on this one? Nope, because it's a plus. So 2x, x squared plus 9, x plus 3, x minus 3. Then you're done. Questions there? Again, you want to make sure you go as far as you possibly can. Linear factors means you got it as far as you can. Yeah, this one's still quadratic, but unfortunately when you have the sum of two perfect squares, that will not be factorable any further, so you are done. Ask questions, guys. Ask stuff that's going through your head. Okay? Try this one. X to the 4th minus 2x squared minus 8. Do I have a greatest common factor this time? Nope.
No.
Okay. No greatest common factor. Okay. This one probably looks similar to ones that you've had before, but you've never had powers of 4 on it, right? You've had like x squared minus 2x minus 8, but never x to the 4th. The nice thing is, you can do it just like you did those. Okay? what times itself gives you x to the fourth?
X
X to the second. And what two numbers multiply to negative 8 and add to negative 2?
Negative 4 and 2.
Negative 4 and positive 2. Let's see if that works, just because it is a little bit different. Okay, let's FOIL it back out in our heads. What's x squared times x squared?
to the fourth.
X to the fourth, that's good. Plus 2x squared minus 4x squared. Does that work? And then minus 8? Okay, good. So far so good. Can you keep going? It's there again.
Oh,
It's
Difference of two perfect squares right there. X squared minus 4 factors to what?
X
Plus
X plus 2
X
and X minus 2.
I hate this rule.
And can we go any further? Nope. Done. Okay? Alright, been working just on factoring. I'm going to go one step further and have you guys solve them by factoring now. It's my time.
You got 11 minutes.